Assalamualaikum and a very good evening to Professor Technologist Dr. Ahmad Tamizi. We are from Section 5, Group 3 and we are going to present to you our report for Hydrology project. So let's continue to the next slide. So I am the first presenter. I am Ronadia Izzati binti Zamrid, CF 210212, and I'm going to present to you the first subtopic, which is introduction. So in our introduction, Malaysia has an equatorial environment with high humidity and persistent high temperature. So the northwest and southwest monsoons have an impact on the climate. Rainfall is described as the amount of precipitation that falls as rain on the Earth's surface, which is on land or on the ocean. Rainfall is categorized into categories based on its intensity. Okay, we go to the next slide. Okay, for the next slide is problem statement. So, the several factors of flash flood are increase in water level and the reduction of water storage due to development. The aim of this project is to determine the average rainfall of the proposed, which is catchment area, peak flow of catchment area, river discharge at maximum level, water level, and also unit hydrograph. Okay, so we continue to the next slide. Okay, so we continue to the third subtopic in this report, which is objective. So the objective for our group project is to determine the mean aerial rainfall of the proposed catchment area. And the second one is to analyze the peak flow of the proposed catchment location and discharge of the river at the maximum water level. And the last one is to determine and plot the unit hydrograph for the proposed catchment area. So that's all from me. I will continue and pass this presentation to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhamizah binti Hafiz and my number is CF210308. Okay, now we go to the Department of Irrigation and Drainage. Okay, hydrological data should be collected and processed and disseminated for water resources management, planning and national development. World Meteorology Organization WMO regionally and globally collaborates with UNESCO International Hydrology Program IHP to develop hydrological and water resources research and technology of national interest. This is the official web of the public info budget that we choose and take the info for the data our project. Next, this is a Google Earth Pro, this is an application of the geospatial software tools that display a virtual globe that allow druggists to fantasize about assessment, overlay, and creation of the geospatial about data, but not a true geographic information system. Okay, next, to provide a comprehensive suite of general geospatial data including high-resolution imagery, 3D city spaces, road position panoramic image, detailed road chart, literary imagery, and rich point of interest similar to natural feature, rainfall pattern, and business locals. Okay, lastly, we use the operation to collect the necessary information for our chosen station similar to train profile, pitch grade cross section. This is a GeoEarth Pro application.
Hi, Assalamualaikum. My name is Asrini Shwadamita Shahriman. My metric number is CF210234. For my part, I will present about proposed rainfall station and water level station. The proposed rainfall and water level station for our project are located at Kuantan District in Pahang, where there are 3 rainfall stations, which is Sungai Kuantan in Kuantan Bypass, Sungai Lembing, and Sungai Kuantan in Bukit Kenau. and one water level station at Sungai Lembing. Okay, this figure is all about rainfall station. The first one, Sungai Lembing. The second one, Sungai Kuantan in Bukit Kenau. And third one is Sungai Kuantan in Kuantan Bypass. For the water level station, we choose at Sungai Lembing. Okay, for the next, geographical characteristic. This figure is represent a catchment area for 3 stations. This figure for terrain, profile and gradient slope for path 1 from Bukit Kedau to Sungai Lembing. According to the graph, minimum elevation for path 1 is 30 meter, average elevation is 81 meter, maximum elevation is 165 meter, total distance is 2.76 km, maximum slope 37.3 to 35%, average slope 14.1 to 11.8%. Percent of slope is 0.04%. This figure is for terrain, profile and gradient slope for path 2 from Sungai Lembing to Kuantan Bypass. According to the graph, minimum elevation for path 2 is 12 meter, average elevation is 56 meter, maximum elevation is 249 meter, total distance is 11.4 km, maximum slope 42.4 to 41.4%, average slope 8.1 to 7.9%. Percent of slope is 0.009%. For this figure is cross-section near the water level station at Sungai Lembing. For these 3 figures in this slide is for cross-section for each station. Cross-section 1 at Sungai Lembing, cross-section 2 Sungai Kuantan in Kuantan Bypass, cross-section 3 Sungai Kuantan in Bukit Kenau.
Hi and Assalamualaikum. My name is Putri Nur Emilia binti Muhammad Zamri. So today I will present about chapter 3, data analysis. So the first slide is mean area rainfall. So in rainfall intensity, we have 3 stations, which is Sungai Kuantan Bypass, Sungai Lembing and Sungai Kuantan Bukit Kenau. So total for the Sungai Kuantan Bypass 214, Sungai Lembing 183.5 and Sungai Kuantan is 321. So there are 3 methods, which is first is arithmetic mean method. The average precipitation depth that we get is 239.67 millimeter. So the second method is polygon method, which is total area is 180 and precipitation we got 719. Area time precipitation we got 45,181 kilometer square. And the total precipitation is 251.01 millimeter. And the last one is iso-Hayat method. So the first is average precipitation, total is 325. For the area is 320.4. And area times average precipitation we got 14,342.5 kilometer square. And the total precipitation is 44.76 millimeter.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Nur Agnia binti Muhammad Nazlin and my metric number is CF210324. I would like to present about the hydrograph and unit hydrograph for cross-section profile. This figure shows the cross-section of a river. To determine the discharge value, the calculation is repeated for the remaining data until 32 days. Next, plot the graph. Q equal to A times V, where Q is discharge in meter cube per second, V equal to velocity meter per second, A equal to flow area in meter. V is determined by using the Manning's equation, where V equal to 1 over n times R power of 2 over 3 times S power of 1 over 2, where n is Manning roughness equation, R is hydraulic radius, S is slope. So the data is S equal to 0.04, N equal to 0.02, and P equal to 99 meter. Next is graph of discharge versus time. The first is graph of discharge against time, and the second graph is graph of discharge against time base flow separation using straight line method. Next, for the result is, the first column is days, the second column is Q total flow in meter cube per second. The Q total flow is same as the discharge. The third column is Q base flow in meter cube per second. The Q base flow is get from the graph of base flow separation using straight line method. The fourth column is Q direct flow in meter cube per second. The Q direct flow is get from Q total flow minus Q base flow. And lastly, UH ordinate in meter cube per second per cm runoff. And lastly, the detail of river specification shown as below. Catchment area in kilometer square is 232. Total direct runoff in meter cube equal to 15.3 times 10 power of 8. Equivalent runoff depth in cm equal to 659.48. From the previous slide, the total value of direct flow is 424,763.49 meter cube per second.
Peak flow estimation of a catchment area. We use rational method. So I value is 225.58 millimeter per hour. QP value is 152.27 meter cube per second. Figure in this slide, we are using cross-section profile of the river. S value is 0.04, N value is 0.02, P value is 99 meter. Q at the maximum water level is 329,781.39 meter cube per second.
Okay, so the first one is water flow. Water flow is, we will be understanding soil structure requires an understanding of slope and river cross section. The calculation of water flow are calculated daily to obtain the cross section area and the height of the water level Y by using the formula Q equals to AV, which is A is the area of the cross section and V is the velocity. So we will obtain the value of water flow Q day by day. Okay, so the second one is unit hydrograph ordinate. The unit hydrograph may be defined as the direct runoff outflow hydrograph resulting from one unit of effective rainfall, which is uniformly distributed over the basin at a uniform rate during a specific period of time, known as unit time or unit duration. Total stream flow during a precipitation event includes the base flow existing in the basin prior to the storm and the runoff due to the given storm precipitation. Okay, for the third one is straight line method. In this method, the separation of the base flow is achieved by joining with a straight line in the beginning of the surface runoff to a point on the recession limb representing the end of the direct runoff. Okay, for the third one is straight line method. In this method, the separation of the base flow is achieved by joining with a straight line in the beginning of the surface runoff to a point on the recession limb representing the end of the direct runoff. Okay, so this is the mean area method, which is Tyson polygon method, arithmetic mean, and also isohedral method. These three methods we use to calculate the mean areal rainfall and determine the value of precipitation, how much is the millimeter. Okay, so we go to the next, which is conclusion. Okay, last but not least, in our hydrology report, which is conclusion. In this conclusion, there are several steps in order to obtain the data of the rainfall and water level at a certain station, which are by recognizing the water flow, straight line method, unit hydrograph ordinate, arithmetic mean method, Tyson polygon method, and also isohedral method. These methods can ensure that the water level at a certain area or certain station are at the safe level and identify whether there is any possibility of the stations will overflow. When the data can be obtained earlier, the government or the authorities can warn the people around the area for any flood possibilities and have a proper plan for evacuation.